Myself, Dr. Lingraj Amangadi, working as Assistant Professor, Government First Grade College, Kudi. This is e-content for BSc 6th semester, subject Mathematics, session number 12. Its topic is definition of radius of convergence of the series. Definition of radius of convergence. Let summation n from 0 to infinity equal to a0 plus a1 plus a2 plus so on be a series of positive terms from elementary calculus if the limit of modulus of an plus 1 by an as n tends to infinity is equal to L is exists, then by D'Alembert's ratio test the series is converges for L is less than 1 and diverges for L is greater than equal to 1, and if L equal to 1 the test fails. In the case of the power series of the form summation an x to the power n from 0 to infinity equal to a0 plus a1x plus a2x square plus so on, a0 is not 0, it is given in equation 1. If for each an is not 0 and if for a fixed point x equal to x is not 0, we have limit of modulus of an plus 1 x to the power n plus 1 by an x to the power n tends to infinity, that is equal to limit of x to the power n plus 1 by x to the power n is x, that is an plus 1 into x by an, that is equal to modulus of x into y is modulus of x into modulus of y. For that is equal to limit of modulus of an plus 1 by n into modulus of x as n tends to infinity, but limit of an plus 1 by n as n tends to infinity is equal to 1 by r, that is equal to 1 by r into mod x is equal to L, because limit of an by n plus 1 is as n tends to infinity is equal to r provided the limit exists. By D'Alembert's ratio test, the series is converges for L is less than 1 and diverges for L greater than 1. Then the power series equation 1 converges for 1 by r mod x is less than 1. This implies mod x is less than r, or it diverges if mod x is greater than r. R is said to be the radius of convergence of power series equation 1. The interval minus r plus r is said to be the interval of convergence. Also, the radius of convergence by Cauchy's root test is given by r is equal to 1 by limit of modulus of an to the power 1 by n as n tends to infinity. Since r equal to infinity for the series equation 1, the interval of convergence of the power series is minus infinity to plus infinity, that is the real line. We use the following results. That is, first point is a power series represents a continuous function within its interval of convergence. Second point is a power series can be differentiated term-wise within its interval of convergence. Now example, determine the radius of convergence and the interval of convergence of the following series. First one is summation n plus 1 square into x to the power n. Second one is summation x to the power n by 3 to the power n, and third one is summation n plus 1 factorial into x to the power n. Solution here an is equal, for a first example, here an is equal to n plus 1 square, therefore an plus 1 is equal to n plus 2 square. Now the radius of convergence, that is r, is equal to limit of modulus of an by an plus 1 as n tends to infinity equal to limit of, now an is n plus 1 whole square, an plus 1 is n plus 2 whole square as n tends to infinity equal to limit of, now the index is same, the base is different, for that it is limit of n plus 1 by n plus 2 whole square as n tends to infinity equal to limit, now take n common, n into 1 plus 1 by n dividing by, here take again n common for the denominator, n into 1 plus 2 by n whole square, that is equal to n cancel, limit of 1 plus 1 by n divided by 1 plus 2 by n whole square as n tends to infinity equal to, as n tends to infinity 1 by n tends to 0, 2 by n tends to 0, 1 plus 0 by 1 plus 0 whole square equal to 1 by 1 whole square, that is equal to 1. Therefore, the radius of convergence, that is r, equal to 1 and the interval of convergence is minus 1 plus 1. Now second example, here an is equal to 1 by 3 to the power n. Therefore an plus 1 is equal to 1 by 3 to the power n plus 1. Now the formula for radius of convergence is r equal to limit of modulus of an by an plus 1 as n tends to infinity equal to limit of an is 1 by 3 to the power n divided by an plus 1 is 1 by 3 to the power n plus 1 as n tends to infinity equal to limit of 3 to the power n plus 1 by 3 to the power n as n tends to infinity. Now 3 to the power n cancel equal to limit of 3 as n tends to infinity. 3 is independent of n, that limit is equal to 3. Therefore, the radius of convergence, that is r equal to 3, and the interval of convergence is minus 3 to plus 3. Now last example, here an equal to n plus 1 factorial. Therefore an plus 1 equal to n plus 2 factorial. Now the radius of convergence, that is r, is equal to limit of modulus of an is n plus 1 factorial, an plus 1 is n plus 2 factorial as n tends to infinity equal to limit of n plus 1 modulus of n plus 1 factorial, but n plus 2 factorial can be written as n plus 2 into n plus 1 factorial as n tends to infinity equal to limit of modulus of n plus 1 factorial, n plus 1 factorial cancel, that is 1 by n plus 2 as n tends to infinity. As n tends to infinity, 1 by n plus 2 tends to 0 equal to 0. Therefore, the radius of convergence, that is r, equal to 0. Revision: convergence of series by D'Alembert's ratio and Cauchy's root test, and definition of radius of convergence. Thank you.